Okay, here goes. Venn diagrams were created by an English mathematician named John Venn. And what they are is they're a way for us to represent sets and their elements with a picture. So instead of roster form, we can use a picture to investigate different sets and the relationships between those sets. Let's take a look at a basic two-set Venn diagram. It's going to look like this. One of the circles represents one of the sets. We'll call it set A. The other circle represents another set. We'll call it set B. And then what the rectangle does is that frames in our universal set for us. So there's our set A, set B, and the universal set. Now, within this Venn diagram, we have different regions. We have region 1, region 2, region 3, and region 4. Those Roman numerals are on purpose. Anytime we name the regions within a Venn diagram, we're going to use Roman numerals. The reason for that is on Wednesday, we're going to look at problems where we put the number of elements that are in each region in there, and that's going to be the normal numbers that we use. But for naming the regions within a Venn diagram, we're going to use Roman numerals, and those are them. Regions 1, 2, 3, and 4. We go through this, make sure you ask questions whenever you have them. Okay, what is today about? Shading Venn diagrams. We're going to shade two-set Venn diagrams. And the first thing we're going to look at is the intersection. We're going to shade the intersection of sets A and B, or A intersect B. Since we're making a two-set Venn diagram, we'll need to draw one over here. There's set A, set B, frame that in with the universal set. And remember, when we're looking for the intersection, we're looking for the elements that are in A and in B, the elements that are in both sets. We're looking for the overlap. Now we have a process for this. The more of these we do, and especially those of you who are really visual in nature, this will be something you do really quickly. But to show you kind of a process of how you might go about this if you're not very visual and you don't see things right away, is you can do this step by step. We're going to shade set A. So there we go. I shaded set A. And now because we want the intersection with set B, I'm going to shade set B in the other direction. I have the advantage of multiple colors. You may not, and that's okay. You don't need multiple colors because we're going to shade it the other direction. Here's set B, shaded the other direction. And the reason I shade the other direction is because we're looking for the intersection. So now I'm looking for where these overlap, the elements that are in A and in B, the elements that are in both sets. And so what I'm looking for is I'm looking for this crosshatch right here where I have both. And then just to sort of finish this off and make it very obvious what my answer is, I'm going to go ahead and take one more step here and draw this in. And what we end up with is just this shaded. And that would be A intersect B. It's just region 2. That's it. The only reason that's shaded for A intersect B is region 2. Let me know if you have questions on that before we look at union. Okay. Down at the bottom, we're looking for A union B. Remember that union is the elements that are in A or in B. We are just going to join those two sets together. So if we're going to draw A union B, we'll start out with our sets A and B and our universal set to box them in. And now this time, we're looking for union. Some of you might see it right away and go, well, yeah, obviously, color in both circles. You'd be right. But if you don't see that right away, what we're after here is this. We want A joined with B. So here's set A, and set A is everything inside that circle that is for set A. So if we're shading set A, we're doing the whole circle of set A. Everything in that circle is in that set. And now because it's union, we're not going to shade the other direction. We're going to shade the same direction because we're just joining these together. So I'm going to shade B in the same direction. I don't care where they overlap. That's not important to me. I'm just joining these together. And so this right here is our picture for A union B. It would be regions 1, 2, and 3. Let me know if you have any questions on shading A intersect B, shading A union B. Outstanding. Very good. Okay, let's throw a little more complicated into the mix. If we want to shade the complement of a set, for example, B complement. So we're looking at two set Venn diagrams for right now. So it's a two set Venn diagram, even though we've only been given instructions about one set. So here's set A, here's set B, and we have our universal set. And now if I want to shade B complement, that's everything outside of B, but inside the universal set. So that's everything that's outside of B, but inside the universal set. And so there it is. That's everything outside of B, but inside the universal set. That's regions 1 and 4. Complement can be challenging. So if you have questions, please ask them. Shading Venn diagrams is sometimes difficult for students, especially if you're like me and you're not that visual, you don't just sort of see things right away. It can take a little work and a little time to get comfortable with these. On Wednesday, when we do problem solving with Venn diagrams, that's much less abstract. It's very concrete and usually goes extremely well. It's shading that is sometimes challenging. So please ask questions when you have them. All right, now we want to do A complement union B down there at the bottom. A complement union B. So now I've got a complement and a union. This is the most complex shading we've done so far. We'll start out with just a two-set Venn diagram that's A and B with the universal set. And I'm supposed to shade A complement union B. So I'm going to start out just by shading A complement. That's everything outside of A, which is here. And then because this is union, I'm just going to join it with set B. So I need to color in set B. And I do that. This is already colored in. And that's my picture. That is A complement union B. A complement joined with B. And I end up with regions 2, 3, and 4 shaded or colored in. Let me know if you have any questions on that before I give you a chance to try one. Okay. I'll make a poll for this. I want you to shade B complement intersect A. If you're thinking, how in the world are you going to ask this question? Because we can't really draw this picture and show it to you. That's true. A way that I can ask a question like this in our environment is to have you tell me which regions are shaded. So shade B complement intersect A, and then identify the regions that have been shaded. The keys here are to be patient. Make sure you know what complement means. Make sure you know what intersect means as you go about trying to create this picture of this Venn diagram. Like I said before, I don't think these are necessarily easy. In some ways, what we covered today might be the most challenging content we have leading up to exam one. So if you struggle a little, that's all right. Keep working at it and make sure you ask whatever your questions are. If you get something that's not shown at all, make sure you pick the one that's closest to what you have. And then when we go through it, if it's not cleared up, make sure you ask your questions. We'll go another 30 seconds on this and then talk through it together. I know it's a new idea, so it might take a little time to get there. All right, let's see how we did on this one. Okay, some agreement, but we're really spread out among all of those. Looks like 1, 2, 4 seems to be the most popular answer. Let's take a look at this one. If you see something that doesn't make sense, make sure you ask about it. So we're going to start out by drawing our Venn diagram here. I have set A and set B, my universal set out here. And then what I'm supposed to shade here is B complement intersect A. So I'm going to start by shading B complement. That's everything outside of B. And there's B complement. If you don't see how that's B complement, now's a good time to ask because we're going to keep going forward. So there's B complement. Now, what I'm asked for here is where does this intersect set A? Since it's going to intersect set A, I'm looking for the elements that are in both sets. They're in B complement and they're in A. I'm looking for the overlap is what I'm looking for. And so I'm going to shade set A the other direction. I'm going to shade all of set A in the other direction. And now I'm looking for the overlap, the crosshatch, where I have some going this way and some going that way. That's what I'm looking for my answer here is where do they overlap? And where they overlap is just right there. So if I was going to draw a final picture of my answer here, I would have set A, I would have set B, I'd have my universal set, and then where those overlap, B intersect A, or excuse me, B complement intersect, oh, sorry about that. B complement intersect A, where the overlap is, I got to get rid of some of my blue, sorry. Some of you are looking at me going, no, that's not right. Where they overlap is just right here. That's where my crosshatch is. So if I'm going to draw a final picture of this, I've got set A, I've got set B. And so my picture of B complement intersect A is just right there in region 1. That's it. B complement intersect A is just region 1 because that's where they overlap. I do want to point out 1, 2, 4 was our most popular answer for this one. And if you look at this is region 4, this is region 1, this is region 2. If the question had been B complement union A, then it would be regions 1, 2, and 4. But that wasn't the question. We weren't joining those together. Instead, we were finding the intersection. of B complement and A. And so we need where they overlap, which is only region 1. That's it. So union would have been 1, 2, 4. Intersection where they overlap is only region 1. Let me know if you have any questions on what we did there before we take this up a notch. Okay. 3 set Venn diagrams. Now we can have 3 different sets that all overlap with each other and also don't. The way we're going to draw a standard 3 set Venn diagram is we're going to have set A and set B, just like we've had before. And now we need to draw a 3rd set, and we're going to put it down here at the bottom. There's set C, and then our universal set goes around the outside. What this does is this creates a lot more regions. Now, we're still going to name them with Roman numerals. We're going to have region 1, 2, 3, 4, 5, 6, 7, and 8. So we're going to have 8 different regions in our 3 set Venn diagram. Sometimes I'll say 3 set, sometimes I'll say 3 circle, means the same thing. So we have a 3 set Venn diagram with sets A, B, and C, and this is how we're going to name those regions. 1, 2, 3, 4, 5, 6, 7, and 8, and we're going to use Roman numerals when we name those regions. Let me know if you have any questions on this before we start going through some examples of 3 set Venn diagrams. All right. Let's start by just shading set A. We'll keep this simple. So we're doing a 3 set Venn diagram. So I'm going to have set A, set B, set C. And my universal set goes around the outside. All we're doing is shading set A. Well, set A is all the stuff inside the A circle. That's all there is to it. If I want to shade set A, it's everything inside the A circle. That's it. If you're thinking, well, some of that's in B. Yeah, that's okay. You're right. Some of it's in C. You're right. Some of it is. Because A and B might overlap a little. A and C might overlap a little. But what we want to identify here is everything inside set A. So we color in that entire circle. And then the regions there would be regions 1, 2, 4, and 5. That would be set A. Regions 1, 2, 4, and 5. Before I go forward, I want to give you a chance to ask any questions that you might have. Okay. Next up is A complement. So again, we're going to start out with sort of a blank 3 set Venn diagram with sets A, B, and C on there, and our universal set. And what we want to do now is we want to shade A complement. So that's everything outside of A that's inside the universal set. So it's definitely going to include all this stuff out here. But there's more to A complement than that. Anything outside of A is in A complement. So essentially, one way to think of this, those of you that are really visual, is imagine you color in set A, and then whatever's not shaded, you shade it. Whatever's shaded, you unshade it. It's like flipping a light switch. So it's everything but that circle that is set A. Everything else. And that's our picture of A complement. That's regions, let's see, 3, 6, 7, and 8. Regions 3, 6, 7, and 8. Let me know if you have any questions about that one before we move on to A complement B, or excuse me, A intersect B down at the bottom. The math doesn't work. All right. Feel like we're doing okay, but the last poll didn't go great. That was more about intersection and union than it was about the Venn diagram, I think. So we'll see as we get into more practice later on today, but let's take a look at A intersect B for now. So we're going to have a 3-circle Venn diagram. ABC. And there's our universal set on the outside, and we're after A intersect B. Some of you can probably draw A intersect B in there right away, no problem, got it. Others might want to do this in a step-by-step approach, and that's totally fine. A intersect B. I'm going to go ahead and shade set A, and then so that I can find the overlap, I'm going to shade set B in the other direction. And so the overlap of these two sets is just what's in here. Very similar to what we had before when we had intersection on a two-circle diagram. And so as we do this, sometimes it can kind of be like a cartoon strip where I'm going to go ahead and move over here and draw my next one. That'll be my answer for this. I have A, B, C. I have my universal set. And over here on the right, all that's going to be colored in to be the answer is right here. And that's regions 2 and 5. Sometimes, and frankly, I'm a little surprised it hasn't come up yet. Sometimes with that picture, students want to know, well, wait a minute, how can you have region 5 in there? Region 5's in set C. This set A intersect B. What are you doing with part of set C in here? Well, what we're looking for is all the elements that are inside A and inside B. So anything that's inside A and also in B, we want to keep it. And this is where A is. And this is where B is. And so where they overlap, the elements they have in common are in both of those regions. Some of them happen to be in C. Okay, we're looking for the overlap of A and B. If some of those happen to also be in C, so be it. Any questions on any of those three before I give you a chance to, oh, we might want to do one more example before I have you try one. Yeah, one more example before I have you try one. We're going to do A union B. Union is joined together. So with our three-circle diagram, we've got set A, set B, and set C. And we're going to shade A union B. So it's A union B. I'm joining them together. I want anything that's in A or in B. If you're in A, I'm keeping you. If you're in B, I'm keeping you. All right, well, we'll shade set A. And since this is union and we're joining together, I'm going to go ahead and shade set B in the same direction. And what we wind up with shaded here, it looks like region 1, 2, 3, 4, 5, and 6. Same question might come up sometimes for some students. Wait a minute, some of these are in C. Yeah, that's true, some of them are. But what the question said was shade A union B. Anything that's in A joined with anything that's in B. If some of those happen to be in C also, so be it, no problem. Anything that's in A gets shaded, anything that's in B gets shaded, join those together, and we wind up with these 6 regions shaded. Okay, now I want to give you a chance to ask anything before I have you try one. All right, this is either going really well or really poorly. And here's a chance for us to kind of find out. 3-set Venn diagram, I want you to shade B intersect C, and I'll make a poll for it. That's okay, Saul. I'm glad you're here. It might be hard to jump in with where we're at, but if you see a couple examples and feel like you can, then that's great. For the last one, the reason the poll didn't go as well as I hoped was a misunderstanding of the difference between intersection and union. Be careful on that here. This one's asking us for the intersection of those two sets. We'll go another 20 seconds on this and then talk through it together. All right, let's see how we did. Oh, really strong agreement this time. All right, hopefully that's good news. Let's go take a look and see how we get this one shaded. All right, so we're supposed to shade a three-set Venn diagram. So we're going to start by just making a three-set Venn diagram. So there's set A, set B, set C, and our universal set to frame everything in. Okay, we're trying to shade B intersect C. It's intersect. So right away, I know that I'm looking for the elements that are in both sets, the elements that are in B and C, the elements that are in the overlap of those two sets. And since I know that, because I was asked for intersection, what I'm going to do is I'm going to shade these in different directions. So first I'll shade set B, and then I need to shade set C, but because I'm looking for the overlap, I'm going to shade the opposite direction. And now I'm looking for where the crosshatch is. What do they have in common? Where do they overlap? And that's right here, in this piece right there. To sort of clean this up a little, I'll go ahead and take a second and redraw my final picture with sets A, B, and C, and box them in with the universal set. And then the only thing that's going to be shaded in the end here is right here, and that's regions 5 and 6. That's by far our most common answer. That's really great. I feel much better after this poll. If you have any questions about what we did there, make sure you ask. Please make sure you're confident with the difference between intersection and union, because the union of these would be 2, 3, 4, 5, 6, 7, but we weren't asked for the union. We were asked for the intersection, which is the overlap. What are the elements that are in both sets? The question will tell you. Yeah, the question will tell you. Good question. All right. Let's climb a little further up the mountain and look at A intersect, B union C complement. So we've thrown it all in this one. We have intersection, we have union, we have parentheses, and we have complement. This is about as challenging as we can make one of these. So let's be patient and go through this one together. Okay, it's a three-set Venn diagram, so I'm going to start out with just a blank one with sets A, B, and C. Put in my universal set. Okay. And based on what I know about how parentheses work, the first thing I need to do here is B union C. Some of you will be able to at this point, you can just see B union C, color it in, great. If that's you, fantastic. Others might still want to do this one step at a time, and that is totally fine. This is pretty new for you, I'm guessing. So B union C, union tells me we're going to join those together. So I'm going to shade set B. And because I'm going to join this with set C, I'm going to go ahead and shade set C in the same direction. So what I've got so far is B union C. You don't have to do this, but if it helps you, you can jot down what you've shaded so far. It's regions 2, 3, 4, 5, 6, and 7. You don't have to do that. But if it helps you, great, do it. Okay, what I'm supposed to do next then is the complement of whatever it is I currently have shaded. So I'm turning this inside out. If you've ever played the game Othello, where you have black and white discs, and when you put yours in the right place, it flips a whole bunch of them over. What we're doing here is we're flipping all these. We're taking the complement of what we have now. So anything that's shaded won't be, anything that isn't shaded will be. And so in our new picture here, set ABC, now what I want to have shaded is, well, region 1 wasn't shaded, region 8 wasn't shaded, and I think that might be it. That's where doing this might come in handy. Previously, 2, 3, 4, 5, 6, and 7 were shaded. Well, the only ones left are 1 and 8, and so it's 1 and 8 that are going to be shaded over here. B union C complement is what we've got in the picture on the right with the blue shading. That's B union C complement. If any of these steps don't make sense, you don't see why a region is shaded or it isn't, or you're not sure where something came from, it's perfectly fine to ask. I want you to. Chances are somebody else has the same question. Okay, we're sitting here with B union C complement. The only thing left for me to do is find out, where does this intersect set A? Where does it intersect set A? Where does it overlap set A? So that means I'm going to shade set A the other direction. And when all this is said and done, when it all shakes out, what I'm looking for is, where is the overlap of A with B union C complement? And the overlap of A with B union C complement is just right here in region 1. That's it. And so what we end up with for a final picture here for A intersect B union C complement is just region 1. That's it. It's important to follow order of operations. Parentheses told us what to do first. That was B union C. Then, because there's an apostrophe on there, the next thing I need to do is the complement of B union C. And that was in light blue. And then I needed to know, where does this overlap with set A? And so I'll draw in A intersect. I'll do it the other direction and look for the overlap, which was here. And so my final picture turns out to be just region 1 shaded. Yeah, Laura, you're right. The region 8, right? Region 8 that's out here outside any of the circles, that's only going to be put in play when we're talking about the complement. That's a good observation, and you're exactly right. Because, and the reason for that is, if we say set A, we're talking about the stuff inside this circle. If we're talking about B, we're talking about inside this circle. And if we're talking about C, we're talking about inside this circle. So the only way to get out of those circles is to have a complement. Now, a problem might have a complement in it, like this one did. And at the end of it all, region 8 is not shaded. That's certainly possible. But in order to bring region 8 into play, we're going to be talking about a complement of one of the sets. At least one of the sets. Oh, very good. All right. Okay, let's have you try one. We don't have parentheses here. So we're just going to go from left to right. We're going to do A intersect B, union, C complement. I think it's a pretty challenging question. I'll make a poll for this one. No parentheses, so we're just going left to right. A intersect B, whatever you end up with, union, C complement. I'll make a poll. I don't normally put I don't know in a poll, but it's there to kind of help give you a chance to say, I'm really struggling with this. I need you to go through it a heck of a lot slower or something. Hopefully, I don't know isn't a very common response, but I did want to make it possible. It's a step-by-step process when we have multiple things to do like we do in this one. So be patient as you go through them. So we'll draw this one step at a time. If you get an answer that's not there, you can pick I don't know. And we'll go another, let's say 20 seconds on this one. All right, let's see how we did on this one. Okay, we've got some agreement, but we're kind of split between two of them here. So let's be really patient and careful as we go through this. what I'm getting a sense of is that the issue isn't so much with the Venn diagram as much as it is with intersection and union. So that's interesting. That's very interesting. Not that's not typical, but it's an easy one for us to address. So let's take a look at this. So I'm going to start out with my 3-set Venn diagram where I have A, B, C, and box it in with my universal set. The first thing I'm supposed to do here is find A intersect B. Some of you can probably visually just look at this and go, well, A intersect B is right there. If that's you, fantastic, great, do that. If you're not there yet, that's okay. A intersect B. Intersect means I'm looking for the overlap. I'm looking for the elements that are in both sets. So I'm going to shade set A one direction, and then I'm going to shade set B the other direction, and look for where those overlap. And we'll go ahead and just draw this. It's kind of like a cartoon strip. When I have sets A, B, C, and my universal set. And what I have shaded right now is just right here. Just those two regions right there, regions 2 and 5. If you don't see that, it's okay to ask about it. And like I said, if you see A intersect B and you go straight to here, great. That means you're doing well, and you can run with that. Okay, up next, what I'm supposed to do here is I am supposed to join this with C complement. So union means join together. So I'm just going to join what I have now with C complement, everything that's outside of C. So whatever I have shaded now is going to stay, and then I just need to tack on C complement. All right, well, that's everything outside of C. Everything outside of C. And sometimes that can be a little hard to visualize. So if you just sort of imagine here is set C, so I need to make sure I do everything else. So everything outside of C, that's going to include this over here and this over here, and that's got it. So I have A intersect B union C complement. What I end up with for my final picture here has region 1, 2, 3, 5, and 8 shaded. I'll come back to that in just a minute, Salia. There's something I want to address first. The most common answer was the correct one here, which is good. The second most common answer here left out region 5, and I think I know why, and we'll talk about it a little bit. Complement is not the easiest idea in the world, so students can kind of put blinders on when it comes to complement. And what happens is you see, well, this says C complement, so nothing in C. And while that's true, you have to remember what this question asked us to do. You look at region 5 and you say that can't be in the answer because it says C complement in the problem. And if we were just drawing a picture of C complement, you'd be right. But we weren't. We were drawing a picture of where does A intersect B? What does that give you when you join it with C complement? So we are joining these two things together. We are joining A union B, or excuse me, A intersect B, whatever that is, which A intersect B includes region 5. Region 5 is shaded when we do A intersect B. And so that's going to be, region 5 is shaded right now. And what we're going to do is we're going to join that with whatever C complement is. Now, C complement does not have region 5 in it, but because A intersect B does have region 5 in it, and we are joining these things together, that's why region 5 is shaded as a part of our answer. So just because we see this in the problem somewhere doesn't mean can't have region 5. That's not what it means. I understand why you would think it. So it's not a crazy thought. But because what we're doing here is saying we're gonna do C complement and we're gonna join it with this other thing. And if this other thing has region 5 in it, then our answer will have region 5 in it. Let me know if that doesn't make sense. It's a very common challenge for this problem. In some ways, it's the reason we do it in class, is so we get a chance to talk about that. Salya, when you say we label each section, do you mean, and hang on a minute, I won't find it right away, but I'll try. That. The 1, 2, 3, 4, 5, 6, 7, 8. Okay. And those are just Roman numerals, the numbers 1, 2, 3, 4, 5, 6, 7, and 8, but we're not going to use, we have another purpose for the numbers that are in the way we normally write them. So if you've ever seen a clock with Roman numerals on it, this is 1, 2, 3, 4, 5, 6, 7, 8. A V is 5 in Roman numerals. And actually, Roman numerals is something we're going to cover later in the semester in more detail. For right now, I just need you to know 1, 2, 3, 4, 5, 6, 7, and 8. That's it. And that's a way for us to name those. Yeah, it's 1, 2, 3, 4, 5, 6, 7, 8, just like that. So basically like reading a book. We're going left to right. We do the top row, then the next row, then the next row, and then the bottom row. Perfect. Very good. Are there any questions about shading those 3-set Venn diagrams? Okay, great. So far, we've looked at taking symbols and turning that into a Venn diagram. Now we're going to bring in one new element where we incorporate statements that we're going to put in a Venn diagram. So we've been given these 3 sets. Set A is people who like apples. Set B is people who like bananas. And set C is people who like cherries. What we're supposed to do here is use symbols, which is A, B, C, intersect, union, complement, and a Venn diagram to identify the people who like apples and bananas. So we want the people who like apples and bananas. You may find it easier to go to the diagram first and then the symbols. That's not common, but you might. It's okay if you do. I'm going to go to symbols first and then draw the diagram from there. So people who like apples, well, those are the people in set A. And that's overlap, intersection, and the elements that are in both sets. They like both apples and bananas. So that's going to be intersection. And bananas is set B. So I'm going to draw a 3-set Venn diagram here and have A intersect B is the people who like apples and bananas. As far as symbols go, that's it right there. People who like apples and bananas is A intersect B. And then in a diagram, ABC, A intersect B is right there in regions 2 and 5. That's where A and B overlap. Those are the people in this picture who like apples and bananas. Just to sort of re-emphasize it, here's the people who like bananas. Or here's the people who like apples. Here's the people who like bananas. I'm looking for the people who like apples and bananas. They like both. And that's right here in the overlap of those 2 sets. Now, you may say, what about set C? Well, some of those people don't like cherries and some of them do. That doesn't matter. What we were looking for here is where are the people who like apples and bananas? And it's regions 2 and 5. Let me know if you have questions on that. We're going to try a couple more of these. Okay, so I have the same 3 sets. Use symbols and a Venn diagram to identify the people who like apples or bananas. I'm going to give you a chance to try this. I'm not going to make a poll for it or necessarily ask you about it. I just want to give you a chance to try it before I go ahead and dive in. So we're after 2 different things here. We want symbols and a Venn diagram to identify the people who like apples or bananas. And basically, I'll just be a little patient here and give you a chance to try it. Okay. The key word here is or. Or. They're in apples or bananas. That's union. I'm going to join these two sets together. And so what I'm looking at here with symbols is A union B. That's what we're looking for symbols. When I go to put this in my Venn diagram, I'm going to have A, B, C, and then, all right, this is union. I'm just joining these together. So there's the people who like apples. Here's the people who like bananas. I'm just joining them together. That's my picture. And the regions shaded are 1, 2, 3, 4, 5, and 6. And everything in A joined with everything in B. Some of them like cherries, some of them don't. Doesn't matter. We know that anybody who's shaded in there likes apples or bananas. They might like both. Okay, then you'd be in the overlap. If you only like apples, then you're not in the overlap. If you only like bananas, you're not in the overlap, but you're still a part of apples or bananas. Let me know if you have any questions before we look at one more. Okay. Same 3 sets. Use symbols and a Venn diagram to identify the people who like apples but do not like cherries. I'm going to give you one part of this, and I want you to see if you can tell me the other part of this. The word but, we treat that the same as we would treat the word and. This sentence is the same as identify the people who like apples and do not like cherries. So if we see but in a question, we treat it like and. So there's that. Now, how am I going to write do not like cherries? How am I going to write that? Outstanding, Stephen. I don't think that's an easy question at all. And the more people that are understanding that, that's excellent. Good, Katrina. You're exactly right. If you like cherries, you're in C. If you do not like cherries, then you're in C complement. You're outside of set C. You don't like cherries. So here are symbols. Let's see. They like apples. That's set A. But, which we treat like and, which we know is intersection, and do not like cherries, C complement. So in symbols, this is A intersect C complement, and then we can draw that Venn diagram. I want to give you a chance to shade it before I do, so I'll be a little bit deliberate here before I dive in and shade that. So you try and shade A intersect C complement and see what you come up with. All right, it's intersect. So that means I'm looking for the overlap. I need the elements that are in both sets. They need to be in set A and in set C complement. So we'll start out by shading set A. And then because it's intersect, I'm going to shade set C complement the other direction. So that's everything outside of C needs shaded in the other direction. And then because I'm looking for the intersection of these two sets, I'm looking for the overlap of my shadings, and that's here in region 1 and here in region 2. I'll draw a final picture of this to make it a little more clear. When we get all those scribbles in there, it can be kind of hard to see what we ended up with. So we'll draw one final picture here to finish it off. And it looks like all we end up with shaded are regions 1 and 2. That's it. And if you look at the picture and kind of think about it for a minute, what we're saying is we want the people who like apples. Okay, that's these people right here. These are the people that like apples. But we want to make sure that they don't like cherries. So that means we don't want to include anybody who likes cherries, so we need to throw them out. And so we end up with just regions 1 and 2. Let me know if you have any questions on that before we move to one more idea for today. Okay. This is going the opposite direction. If you're given a Venn diagram, can you find the notation that would have created it? Here's what I mean. So we'll just do this with a 2-circle diagram. That's complex enough. And I also want to mention this won't be a main idea for us. It's something you'll see in the homework. I would like it if you're comfortable with it. It's not going to be something that we focus on, but I do want you to be reasonably comfortable with it at least. And so we're given that picture, and it's our job to say, all right, what would the notation be? We've been given a Venn diagram. What notation would get you here? And a key part of this is trial and error is great here. Just try something and see if it works. So if in your head you think, well, what about A intersect B? What would that look like? And I draw my 2-circle diagram with A intersect B, and I end up with this shaded, and no, that didn't work. What if I try A union B? Well, that gives me all this right here. That's no good. And so, okay, I'm trial and error my way through this. And then I kind of look at the picture and I think to myself, wait a minute, what is it that's shaded here? Well, it's everything that's inside B, but outside of A. I don't want any of A to be included. So it's inside B and outside of A. Let's see if that works or not. Let's try B intersect A complement and see if that works. B would be here. A complement, everything that's outside of A would be the opposite direction because we're doing intersection. Everything outside of A, the only thing shaded is region 3 in this 2-circle diagram. And sure enough, that's what I was trying to get. So trial and error is a good way, and think about what it is you're trying to shade. Meaning if it's inside B and outside of A, then inside B and outside of A is likely to be your symbols. Those take some practice. They can be pretty hard sometimes. They won't be a major thing for us. But if you see one, I want you to at least have a strategy of how to approach it.